So the application here is to query your document. Basically, we use a Streamlit, LangChain, and OpenSearch to do that. LangChain is a Python framework and also a JavaScript framework that has multiple tools, and it enables us to contact any other type of large language models, not only OpenAI, but several ones from Hugging Face as well, to build applications powered by those large language models. Streamlit is an interactive web application, and OpenSearch is a robust search engine. We'll go into details of each one of those. So what exactly is Streamlit? So Streamlit is a open source Python library, and that enables the rapid creation of custom web applications, basically for machine learning and data science, but we can use for any other type of application as well. The design, it serves as an invaluable tool, mainly because of the fast prototyping part. So you can design and put to run, even in production, fast applications without the need to have any web development experience, because you pretty much turn script into a web app. And what exactly is LangChain? So LangChain is a software development framework built in Python and also in JavaScript, designed to simplify the creation of those applications using large language models. It provides a standard interface for large language models, integration with other tools and databases, and end-to-end chain of executions. And we have OpenSearch. OpenSearch is an advanced and powerful tool designed to help us locate information on an expensive data set. Think of it as a highly enhanced search engine, specifically that you can integrate with any of your applications. It handles large data sets, returns quick results, and searches through multiple types of data. The architecture of this application is pretty linear. Initially, you have the document loading, which is pretty much loading the PDF or any type of data you have into a LangChain object. Then you have to apply a document splitting. Document splitting basically is get the object document you just loaded, and split that into chunks. That way, smaller parts are based on paragraphs, sentences, or any other type of logical division, depending on the specific requirements of what you are trying to achieve. Right now, we have a limitation of 500 documents, not chunks. And the chunk can be any type of character you want, but that depends on the type of model you're using. We then index those chunks with the OpenSearch and apply the embeddings. So we embed those chunks and index that into OpenSearch to facilitate the search eventually. Then we do the query processing. Pretty much we get the information that the user is requesting, their question, embed that, and do the search through the embeddings you already indexed on OpenSearch. Upon that, we get the results, and we streamline that into Streamlit. Yes, Eduardo.
Hey, Fred, just wanted to ask you a question. When I heard the first time the term embeddings, I didn't know what it meant. It's a kind of a common concept within data science, but I would suggest you, if you could just maybe touch a little bit on what is an embedding, that would be super helpful.
Yeah, absolutely.
Thank you.
Embeddings are a way to represent the text data as numerical vectors. So these embeddings capture the semantics meaning actually of each chunk, and then they are used to make the search process more efficient. It kind of classifies the data by similarity and groups them together, and that kind of makes a fast and more accurate approach on searching data. Okay. Yeah. So next, we once we get the query, we do the embeddings of the query and apply. So we do that classification and find out data from that document that are similar to the question itself, and return that on Streamlit for the user to check. Two key points I want to mention this when you're developing this type of application is data pre-processing is really important to do some data cleaning first so that you can have better chunks and more accurate chunks. You have to be careful not to split an important paragraph in two, and the large language model, upon searching the embeddings, we might lose context on that. The other part are prompts. So prompts are a big part of interacting with large language models. And depending on the type of prompt you use, you might break completely the response or make it 100% accurate. So one line can be a game changer. It's something you have to experiment and see what fits best. And this is important on any type of application when you're using large language models. Let's go to the live demo. Let me share my other screen. So I'm going to go over the code first, and then we're going to see the application running. So basically, we declare the Streamlit and the LangChain library here, load the credentials, do some basic configuration for the Streamlit application. We use this cache resource, and this is important because you don't want to load the document every time you ask for a question. So using cache resource, we load the data only once, and we can reuse that and just pass on the query we want to work with. In here, we are loading an object with the unstructured PDF loader. We load the document itself from the object, and we do the splitting of 1,250 characters. So that way, we have to have less than 15 documents. This is currently a limitation from OpenAI. I'm not sure if this is, can you guys see, actually? I should have asked it before. Is it too
Yeah, we see
small?
the screen.
Okay. We load the embeddings here. We're not sending the file yet. We're just loading the wrapper for the model of the embeddings, and we aggregate everything together in this wrapper for the OpenSearch. We pass the documents already splitted. We pass the embeddings so we can embed that, and the OpenSearch information so that we can index that information. And return the document search. We pick up the query from the user here. Upon having a query, we generate the answer, and this is the prompt. So basically, we get everything we retrieve it from the OpenSearch. We include the question itself, and the large language model will answer back to us, applying this guideline on the prompt. We build the prompt in a LangChain object. We apply the similarity search here, and we pass on to the large language model through a QA chain, resulting in the output. Once we have the output, we print back to the user on the screen. So we have the application running. This is how it shows up on Streamlit. This is a lease agreement file. It's just a mockup file that William Hearn, our friend, gave to us so we can execute. And I do have some questions that he sent and the answers. So when I'm checking a lease agreement, I want to know if pets are allowed. It will go over the documentation and gives me the results. Like, yes, pets are allowed with a non-refundable pet fee of 150. Let's say I want to know what parking ID am I assigned to on this lease. You should retrieve the information that I'm on 441. Is smoking allowed on the property? No, smoking is not allowed. Right now, you can do some large language model configuration to elaborate more on the response, or you can string just to what you have on the documentation. You can mess up with the temperature when using that. The max token does a great job on improving response. But overall, this is how you build an application that would load the document, and you can use it to QA your documents with large language model. So it's pretty simple, pretty basic, but you can can build upon that.